Hello, my name is Ethan Mendes, and this is my Physics 2 Lab 1 assignment. This presentation is broken up into 4 sections: an introduction, observations and measurements, calculations, and finally a model. In this lab, we were asked to investigate the concepts of charges and electric fields with tape. Uh, we use the concepts from mechanics in conjunction with concepts from electrostatics that we learned this semester to analyze the system of floating tape due to an electric field formed by another tape, finding charges, fields, forces, and excess and deficient particles, including electrons and protons. We then built a rough computational model to simulate the actual phenomena observed. And the fundamental physical principles involved were the electric field and the electric force, the force of gravitation, the law of superposition, and the conservation of charge. And I found that the charge of the tape, Q sub b, was positive and had a value of 6.13 times 10 to the negative 9 coulombs. And additionally, the number of deficient electrons divided by the number of surface atoms was 9.79 times 10 to the negative 8 electrons over atoms. And now from observations, the quantitative observations I found are in the table, and I measured the length and mass of tape A and B, the width of the tapes, and the distance between the two tapes when tape B floated over tape A. I also found that when two charged U-tapes were held close together, they were repelled, and this told me that the charge of the U-tapes have the same sign. Also, both my hand and a negatively charged pen attracted the U-tapes, and this told me that the U-tapes are positively charged. Finally, when the base tape was brought close to the other U-tape, it began floating. Uh, Additionally, a final note is that it is important not to touch the U-tapes with your hand, as this will cause the U-tapes to discharge onto your hand and your body, which is a conductor, which will cause experimental error. Now for calculations. So the only forces acting on tape B are the force of gravitation and the electric force, as shown in the free body diagram. And since the tape is not moving, the net force is 0 newtons. And now we can calculate the gravitational force on tape B using principles from mechanics, and also then calculate the electric force on tape B using the formulas for electric field and electric force, as shown here. And this is done in terms of Q sub B. Then we can calculate Q sub B itself by realizing that the net force is simply equal to the force of gravitation plus the electric force. And we can find that Q sub B equals 6.13 times 10 to the negative 9 coulombs. Then we can calculate the number of deficient electrons, which is simply equal to the number of excess protons that we have on the tape, which is equal to 3.82 times 10 to the 10 electrons. Then we can calculate the number of surface atoms, which is simply and we can do this by first calculating the surface area um, of the top of the tape, and then we can use a conversion factor to find the number of atoms, which is 3.90 times 10 to the 17. Then we can calculate the ratio of deficient electrons to surface atoms. We find this to be 9.79 times 10 to the negative 8 deficient electrons per surface atom. And an interesting note is what would happen if electrons were positively charged and protons were negatively charged. And in this case, we'd find that the tapes would actually be negatively charged, and the directions of the electric fields would be in opposite directions. However, much of the experiment would remain the same, as the tapes would still repel each other and one of the tapes would float. And now finally for the model. So to create the model, we have to make some assumptions. First, that there's no air resistance on the tapes. Second, that the tapes have the same charges. And third, the tapes can be represented as point charges. And so to create a model, first we calculate the force due to gravity, which we find here. Then we calculate the electric field and electric force on for some test charge, with Q sub b equaling the charge of a proton, as shown here. Then we calculate the scale factor, which shows us how many times larger Q sub b is than the charge of a proton, given this equation that the gravitational force plus the electric force equals 0 newtons. and then we calculate Q sub B, and then finally we calculate the actual electric field and electric force. Um, so in conclusion, I was able to observe and record physical phenomena and calculate relevant quantities like the charge in the tape and the ratio of deficient electrons to atoms, and finally to create a computational model to confirm my predictions and calculations. Thank you for watching.